This is video number 3 for sections 4.1 and 4.2, Other Types of Exponents. In this video, we need to figure out what happens if your exponent isn't a nice counting number like 1, 2, 3, 4, 5. This stuff gets a little tricky, and in order to figure this out, we're really going to have to rely on the rules of exponents that we just talked about in the last video. I have 3 other types of exponents to show you. The first would be a situation where the exponent itself is a 0. In other words, what do we mean by something raised to the 0 power? You can see that our old definition is not going to work here. I can't take x and multiply it together no times. That doesn't really make any sense. So what I'm going to have to do is I'm going to have to rely on the rules to make sense of this. Let's look over here on the side. What I did is I made up a pretty simple problem here, x to the 5th divided by x to the 5th. Well, if you glance back up at your rules, you should see that this is an exact match of Rule 2, the one about dividing two guys with the same base. And what Rule 2 said is that when you do that, the base ends up on the top. In other words, there is no fraction anymore. And the exponents get subtracted. 5 take away 5 for a final answer here of x to the 0. Let's work out that same problem a different way. What I could do is I could write out x to the 5th as 5x's on the top and 5x's on the bottom. And now I can do all that canceling. And of course, I think it's not too difficult to see that essentially every x has a match that can be divided out top to bottom, leaving me with just a bunch of 1's everywhere. 1 divided by 1 is just 1. What's the point? If these two things are both answers, then they must be equal to each other. X to the 0 is equal to 1. And look, you could make up a bunch of other examples similar to this one here. You're going to get the same result every time. X to the 0 is always equal to 1. And that becomes our definition then of a 0 exponent. Another way you could write that, any base raised to the 0 power is always equal to 1. We know that this is true because of the rules of exponents. Okay, let's try a couple of examples. In fact, I would encourage you to pause the video and try these examples on your own. The first example says we have negative 28 to the 0 power. Well, I hope that this one is very, very easy for you. We just got through saying that any base raised to the 0 power is 1, period. End of story. That's it. How about the second one? Does that mean this is 1 as well? Well, no, not because of the 0 issue, but because of something we talked about earlier. Remember, we said that if you want your base to be negative, it must be in parentheses. There's no parentheses here. The base that goes with that 0 exponent is the 17. This is not a negative 17. There's an imaginary dividing line right there. This is positive 17 raised to the 0 power with a negative sign attached. Well, positive 17 raised to the 0 power is 1 because any base to the 0 is 1, but then I have to attach that negative at the end. This negative was not a part of the rest of the expression. It just hung out there and got attached at the end. So be careful with that parentheses issue. Okay. Let's go on to the second type of exponent we need to look at. Now we move on to negative integers. In other words, an exponent like negative 1 or negative 2 or negative 3. How would we interpret that? Again, our old definition is just not going to work. I can't multiply x together negative n times. That doesn't make any sense. So I have to rely on the rules. Over in the box, I made up a simple problem to help us get there. The problem is x squared divided by x to the 5th. Let's talk about 2 ways of working this out. One way would be to once again use Rule 2 from the last video. It's the same rule we used up here, the one that says, look, if you divide two guys with the same base, the base ends up on top, no fraction anymore, and the exponents get subtracted, top exponent minus bottom exponent. That was the order for an answer here of x to the negative 3. Okay, let's work it out a different way. the long way. X squared is x times x. X to the fifth is 5x's. I could start doing my canceling thing over here. Now I'm going to run out of x's on the top to cancel. And so when I multiply across, 1 times 1 is 1. X makes x cubed. Final answer 1 over x cubed. Again, the point is the same. If these are both answers, then they must be equal to each other. And I think if you look closely, you can see we've come up here with the meaning of a negative exponent. Negative exponents reciprocate the base. Notice that my base used to be x, and now essentially it's 1 over x. When the base gets reciprocated, the sign of the exponent then changes from negative to positive. That's how I have to define a negative exponent. X to the negative n is 1 over x, reciprocate that base, to the corresponding positive integer exponent. Here's the rule. X to the negative n equals 1 over x to the n, or in words, a base raised to a negative power is the same thing as the reciprocal of that base raised to the corresponding positive power. Now, let me work some examples for you to help you see how this works out. Essentially what we're saying is negative exponents are difficult to work with. And so what we generally do is we get rid of them. We change from a negative exponent to a positive exponent by reciprocating the base. Take a look at this first example, 3 to the negative 2. That's difficult to think about, to work out directly, but I know from the definition that 3 to the negative 2 is the same thing as the reciprocal of 3, namely 1/3, raised to the corresponding positive power, namely 2. The base gets reciprocated, the power changes sign. This is now something I can work out. I have a 1 on the top. 3 squared means 3 times 3, which is 9. The final answer here is 1/9. Let's take a look at the second example. This one's a little bit trickier. Okay, if I asked you what the base was this time, you might say 5, and there's a degree to which that's true. But I think if the base is on the bottom, it's probably better to think of it as a 1/5 being raised to the negative 2 power. We can do that since the 5 is there on the bottom. Well, if my base is 1/5 and my exponent is negative 2, and I'm trying to rid myself of the negative exponent, what do? I reciprocate the base. The reciprocal of 1/5 is 5 over 1. I don't really even need the 1. And that allows the exponent to change from negative to positive, and I end up with the surprisingly simple answer of just 25. If you take a look at these two examples, essentially all we're saying is this. If your base is on the top with a negative exponent, it's going to move to the bottom, and your exponent is going to change sign. If your exponent was on the bottom, then your base is going to move to the top, and the exponent will change sign. Take a look at this final example. What I could do here is sort of merge the two things together that we just did in the last two problems here. Here's the way to view this. Each base that's here has a negative exponent. I don't like negative exponents, so I am going to reciprocate those bases and change the signs of the exponents. This top one is a 4. I'm going to reciprocate it to the bottom, essentially creating a 1/4, and now I have a positive 3 exponent. This 4 that was on the bottom is like a 1/4, and I'm going to reciprocate it to the top, which allows me to change the sign of the exponent. This is now very simple to work out. Actually, I can use that rule 2 of exponents, the one that says when you divide like this, the base ends up on top, and you subtract the powers, top minus bottom, for a final answer here of 16. The point is, negative exponents tend to be something we don't like and we try to get rid of, and you can do that by simply reciprocating the base and changing the sign of the exponent. Top stuff moves to the bottom, bottom stuff moves to the top. As long as there's no adding or subtracting of bases, then all our rules of exponents apply, and this will work every time. A student one time told me, jump the line, change the sign. And I thought that was a good way to remember it. If the base jumps the line, the exponent changes sign.